As you guys know, there's a lot of challenges. There's technical challenges and there's business challenges. The number one challenge is standardization and the proliferation of products and projects that are out there, the alphabet soup of things, of protocols and message formats and all these different things. So that's one of the things. If you look at proprietary usually has the one magic ring that's going to solve all your problems. The problem is that there's 83 companies that have built that magic ring. In open source, we typically take the view that each standard or way of working or project is solving a different problem in some way. And it's important for interoperability, for things to work together. And so that's one of the things in Eclipse that we try to do, is try to support as many different standards as possible. It's not feasible, obviously, to support everything. But open is good for customers. I can't tell you how many customers I talk to that say we're tired of being locked in. We're tired of vendor X controlling our destiny. We want to either take a project and participate in that project and consume it, or we want to come to Red Hat or whatever other company, and we want to have you support it. We want to pay you to be our advocate into the community. It's really hard for your average company to go and ingest all the information about IoT and even know about all the possibilities that are out there. To know that, MQTT is better in this use case, and AMQP is better in this use case, and CoAP is better in this use case. So much less that this open source project is better when you're working in transportation because of. So we're going to talk about the general concepts and attributes of an open source solution, the things that you need to think about, and then through the day you're going to hear a lot of different people who have different projects or implementations or things that they've learned that they're going to share with everybody. But I think it's important to sort of set just a general table of what a generic IoT solution looks like. The principles of an open architecture are important. Obviously, open and interoperable, right? You need to be able to pick and choose from the projects that are out there that are going to meet your needs. They need to theoretically and hopefully be able to interoperate with each other so that you can pick the message broker that you need for data ingestion. You can pick an analytics or machine learning package. You can pick, whatever programming languages you want to use. You can pick the different pieces that make sense in your use case. The biggest challenge, though, is that you're integrating two domains of knowledge together that haven't typically coexisted and are to some extent have in the past been unfriendly to each other, especially in companies, which is IT and OT. OT is about long-term return on asset, safety, low rate of change. IT is about, centralization, about standardization, about driving cost out, and availability and a lot of, all the different values that are out there. But fundamentally they're different. So you're trying to find a point where those two worlds can meet and can integrate. So we've talked about this a little bit in the open and interoperable, but you also need a modular infrastructure where you can pick the pieces, as I said, that meet your needs, but yet have them integrated into a system that works as a whole and that is relatively easy for developers to use, is easy, secure, to cost-effective to manage, and you have to do that from the beginning. You have to build in end-to-end layered security from the beginning, because if you don't do that, if if you don't build in end-to-end manageability from the beginning and have that as a design principle, both of those as design principles, your projects will fail. You have to have, not necessarily picked out all the technologies that you're going to use, but you have to have axioms and principles and mechanisms to address all the different challenges that you're going to have as far as manageability and security. And manageability and security really go together because, if you're not updating and actively managing the systems and devices that are out in the field, you're going to be in trouble. You have to assume that any individual given piece of infrastructure at any given time could be compromised, so you have to have defense in depth and layering. So some of the pieces of functionality that you're going to need, you're obviously going to need device and connectivity management, right? You're going to need to be able to connect to the devices, or have the devices connect back to the cloud or to a central data center, have them verify that they haven't been tampered with, update them with the latest software, and then continue to manage the software loads that are on them, manage the configurations, be able to query and get information, or to change the configurations up to and including triggering actuators, triggering switches, triggering physical changes. So that's another real difference between IT and OT, is that in OT you're definitely dealing with the physical world at the very end of the chain, whereas IT more and more, something's up in the cloud on Amazon or wherever, and it becomes less and less linked to the physical world. The other is intelligent edge processing and analytics. More and more we're seeing the trend towards moving data processing, especially streaming data processing, out towards the edge. And the reasons for that are things like latency, because you've got to make a decision in less than a second, transiting over lossy links to the cloud and back. That's not really possible. You need to have survivability in case your connection to the cloud goes down, your factory still works. There's a multitude of reasons to move those out there. The problem is, again, one of administration, security, performance. So you've got to know what to put on the edge versus what to centralize. And then definitely back in the cloud, once you've gathered all this data, you've got to figure out what the hell to do with it. And I can't tell you how many people I've talked to that said we've gathered this entire data lake or ocean or swamp or whatever you want to call it, and they are trying to figure out what the hell to do with it, because they had this big project to get all this data, and now they've got the data, and they're, how do we get value from it? And that's really the hard part, is how do you find the business return out of this? Because the exercise of gathering all this stuff is just the first part, it's not the end result. And so therefore you then need to not only build new applications and gain the insights, but you've also got to integrate with existing application and existing businesses, so that you don't break existing workflows and existing processes, but you may be able to provide new information and insight, or you may be able to use the new applications to do that. And then last again is security and compliance. Security has got to be something that is first and foremost, and the government will, or industry groups will certainly make sure that you do it if you don't. I mean, if you look at Equifax and as the latest one, but all these different issues with data being compromised. If you look at according to news reports, if you look at Target, the retailer in the U.S., their point of sale systems were compromised through HVAC, through controllers on HVAC. So, the vector that they come through is not going to be one that you expect. So you've got to have defense in depth. If you look at some of the white papers that we have, first and foremost among those is the white paper that Benjamin created about the three-tier architecture. And obviously the three-tier architecture is somewhat notional. It may be 4 tiers or 5 tiers or 2 tiers. It's going to depend on your use case. But as a as an exercise, 3 tiers philosophically kind of explains the different levels of functionality, so that you have your connected things, your sensors and actuators and those different pieces that are out there. And they may range from, a little PLC up to an MRI machine. In between those, in a lot of the cases, is going to be a gateway. And the gateways range from a communications gateway to a rack 1U server. So what can be a gateway is very variable. And then there's the integration hub, which is where you bring data in, you analyze it, change it, route it, and we'll talk about this in a minute, and also where you manage the overall IoT environment. And then there's the data management and analytics platform, which is where you're going to do both your streaming and your batch analytics, where you're going to derive the value from the data that you get and turn it into actionable information. And then lastly, you're going to have to integrate that into an enterprise application environment. So roughly, you've got the devices, the things, you've got the gateways, and then these 3 boxes together are the summation of the different pieces of the cloud side of the solution. So, we've talked about the sensors, the actuators, the data sources. Because those are the things you have the least physical control over, they're probably going to be the vector that is compromised. So they're the things that need to be probably firewalled off and distrusted the most. So the more you move from left to right, generally the more you're going to trust sources. But I think it's like the X-Files. In general, the posse should trust no one, right? They have to confirm who they are. They have to, they have to go through multiple levels of security, authentication, authorization to be able to be trusted. And even then, you probably should test but verify and trust but verify. At the gateway, you're going to be provided with functionality like device connectivity, remote management, data transformation, moving data payloads into standardized formats. You may want to do things like when you're in a nominal condition, only sending, instead of sending every 10 milliseconds, send data up once a minute with all the values or averages and mean, median, mode, whatever. And that may change when you get into error conditions. It's up to you and your business and what you need. Intelligent routing. Some data may need to be routed to a data center in Germany if there's data locality rules in Germany. If it's in the U.S., you may route it. U.S. and Canada may route together. You've got to have rules about where to route these things, and you may need to route multiple copies potentially. As well, you're going to execute business logic on the edge typically. It's not going to be super complex, but there will be some complex event processing where you're looking at multiple measurements within a short time window and trying to correlate events together across, temperature, vibration. You may have 4 or 5 different cofactors that you're looking at. And then along with that, you get real-time decision-making, machine learning execution, so the execution of the machine learning models that get interpreted and funneled back down, and then I/O services. At the IoT integration hub, you're talking about at the data center, again, performing a lot of these similar functions. Routing, you're also going to have device command and control, so you're going to be sending southbound messages. You're going to register and manage your devices at this level. You're going to provision them when they initially connect. Message routing again, data collection, collation. Event management is going to be a big one because as things happen, devices die, new devices get added. You're going to have to orchestrate, especially on birth and death of devices. You're going to have to orchestrate a series of events. whether that's, going into ERP systems, going into CMDBs, whatever it is, you're going to have to go and perform a number of actions. Then there's integration services, so you're able to integrate the different applications that need to access the data, and also keep them from being able to, say, write to data they shouldn't be able to, or go and access data in the field or a device in the field. And there's, along with that, access control. At the machine learning layer, you've got data ingestion, sort of the old ETL. You've got real-time processing, so streaming analytics and things like Spark. You've got data storage, because you're going to have to store this for later use in a batch environment to look for new correlations, to look for optimizations of existing correlations. You may get new measures. You may suddenly get a temperature reading that you didn't have before and find a correlation because of that. Real-time analytics and data security. And then at the application development, deployment, integration layer, you've got a very IT developer view of the world. So you need to provide services for those IT developers to be able to integrate, use, and access the data. So you've got your typical app dev and management. APIs are very important at this layer because that's how developers access the world these days. You need to have self-service provisioning so that the developers don't go off and do shadow IT and go up on Amazon and throw up workloads that you don't know about violating potential security issues. You need persistent storage, obviously, for these application developers. And it's got to be polyglot. The developers need to choose the language, just as we talked about with the rest of IoT. They need to choose the language that fits with them the best. And then things like automation, scalability, container portability, development, or deployment flexibility. It's a write once, run in a lot of different places in the world. And as we go on, it's possible that these workloads may be running maybe running on-prem, and then when you have, if you're in retail, when it gets to Christmas time, you have peak load, you may run it on Amazon or whatever. You may arbitrage different cloud providers. So it's important that you have workload portability, you have flexibility about where you're going to deploy them, because I guarantee you, not only will it change because of business reasons, but as you guys know, it's going to change based on how technology develops over the next 10 to 20 years. And that's the horizon that we're really looking at. So if you look at, you see that as you move left to right, you've got that northbound telemetry data that flows up, and you've got that process of protocol translation, filtering, aggregation, and routing, that you have to make the decision based on your use case. Is it more important that every message or every piece of data get through? Is this a transactional system, or is it a system where it's more important that the system stay up and available, and if you miss measurements, that's okay, because you'll get the next measurement within a second. So you have to make those decisions. And then, why open source, and why specifically Eclipse IoT? And this may be preaching to the choir, obviously, at an Eclipse conference, but we think that this is the best source of an end-to-end curated experience. There's 2.5 million lines of code, there's 30 projects, 290 plus developers, so it's enough mass that you're going to be able to find projects that do generally what you need to do. But it's not like some other industrial consortium that are more focused on marketing or other things. This is a community of practice that's focused on actually creating code that's runnable and deployable. And then you can see obviously the list of all the companies that are here and participating. I'll turn over to Marco now.
Sure. Good morning, everyone. So simply, 30 projects, a lot of good building blocks I see, more than 30 projects. These are proven technologies that you can fit into that architecture that James presented, and that gives you the foundation on top of which you can put your IoT projects. So in the next few slides, we're going to be doing a short deep dive in two of these projects. On the gateway side, Eclipse Cura; on the cloud side, Eclipse Kapua. For those of you that were at the conference, it's a little bit of a repeating material, but I'll try to keep it short, and then we'll go on real-world use cases on how these technologies were actually used to solve customers' problems and actually deploy them in the real-world field, right? So we'll start with Cura. So what is Cura? So it is certainly an IoT gateway platform, right? It allows you to manage your gateway, but mostly you can see it as three things. So it's a full application management for your gateway. I mean, it gives you a full web management interface, very similar to what you would get on your DSL router, but you get that to actually manage the connectivity, the network setting, the cellular modem, the firewall, the ports, and all the applications that are running into it. This may not be very important in headless applications like IoT, but it's critical, for example, for the onboarding of your applications, right? You want applications that have API control on, for example, enabling the Wi-Fi in hotspot mode so that the installer can actually go connect to the gateway, put the right activation, enable the provisioning process, and then switch to the station mode. It's also used during the development phases, right, to actually manage all your settings. And if you have programmatic APIs across all the networks, then you can control IP forwarding, port forwarding. You can enable pretty interesting use cases. It's also a rapid application development tool. It lets you visually define data flows that picks up data from many different sources and publish the data up in the cloud without having to write code. You can extend that through different modules. There is a nice marketplace that was presented yesterday, so is it extensible? You can actually drag and drop components from the Eclipse marketplace right into your canvas, and then from there actually expand your application logic. And then last but not least, it's actually a full application development platform. So you have the full power of Java APIs, and then you can develop applications on top of that. If we expand on it a little bit, you can look at this, right? The gateway, as James was presenting in the previous architecture, sits in the middle between the things, right? Your devices at the edge, and the cloud. And what you run in the gateway is the data acquisitions applications, right? So you actually get the data from the field, you process that data, either visually or through your programmatic or through some analytics running off the edge. You aggregate, filter, and then send the data up in the cloud. Cura is polyglot also from the cloud perspective, so if we have built-in connectors for the leading IoT cloud vendors, whether it's AWS, Azure, we have contributions actually. We had contribution from Microsoft to get the Azure connections. We're working with IBM and other actually IoT cloud players to actually make sure that we can connect to them. You can actually open multiple connections to different clouds, so you can actually have your telemetry data sent to one cloud or one server and keep your command and control and device management through an ADA data stream. And we'll see how that was useful in several of the use cases that we have implemented. Of course, if you go for the full-fledged, you get like full application control, right? You have a full development environment, Eclipse-based. You can actually simulate your applications in the Eclipse development environment, develop, debug, step through your code in the laptop, then take that applications and deploy it on the gateway. If we move on the cloud side, it's Kapua. James already described the functional features, the functional boundaries in IoT cloud platform. You have the connectivity management, the data ingestion, some message routing towards the applications. And the two big things are device management and data integration. Device management in the ability to provision, activate, manage configuration, software updates, your devices, all in a secure environment. Data integration in terms of doing storage or integration points in the form of simply something like enterprise service bus towards your applications. All enabled through APIs so that you can actually integrate your apps into your data flows. What Kapua gives you, these are kind of screenshots from the console, but you have REST APIs access into all of them. Device management, you get your registry, connection monitoring, configuration and bundles management. There's also a little concept of a digital twin in the sense that assets or devices that are attached to the gateway can actually expose name channel and strongly type that are actually visible from the cloud and then you can manage from the cloud. So you have REST APIs endpointed directly into the assets attached to the gateway. And as we said, of course, full programmatic access in the form of REST APIs. The critical device management flows are in the provisioning, and we will see that in the use cases, in the management of the life cycle of all the applications, in the management of the configurations of the applications that are running at the edge, in the security end-to-end, both in terms of authentication, authorization, data at rest at the gateway, data at rest in the cloud, and in the whole transports. And when we do large deployment in management of fleet of devices, right? Grouping them, addressing subset of your deployment scenarios, and so on and so forth. There is one other flow, which is the remote access. We'll see that a lot of the Industrial 4.0 use case, for example, they start the monetization process from the remote access. They have the ability to actually access the gateway and from the gateway the machine that is connected to the gateway. That will enable remote maintenance services that before actually required field visits. So it's an easy path to actually start servitization, start adding some services into your offering. Of course, as Red Hat and Eurotech, we have supported versions of the same open source component that we have discussed. You will see these logos in the last of the presentation. So ESF is our supported versions of Eclipse Cura, and Everywhere Cloud ECE is the supported versions of Eclipse Capua. So enough about technology, maybe let's talk about some use cases. So the first one is from a German company, Fresenius. They operate in the clinical and medical sector. Their use case was machines that were actually in dialysis clinics. They are water purifier machines. They are actually installed in the basement of the clinic, and they are not connected. If you are operating in the medical sector, you know how heavily regulated it is. All of these machines have to sustain like a long certification process. Even a small firmware change will actually force you to repeat the whole certification process. So they actually try to keep the machines as simple as possible and just focus on the specific functionality that the machine was designed for. But those machines they have electronics inside, they produce log, they produce statistics, and it's of great value for the manufacturer and also for the people that have deployed the machines to have access to that information. In particular, the nurses in those clinics have to verify 3 times a day that the machine is operating within the allowed range. So they actually have to walk downstairs in the basement where this was installed to actually verify that the machine was within the normal operating range. So the idea here was to actually employ IoT technology to improve the efficiency of all these processes, right? Leave the machine as is, use a retrofit technology, so use a gateway that actually connects to the machines. The gateway will bring the internet connectivity in the form of a cellular connection. It will actually tap to the subnet of the clinic without actually entering the perimeter, so it will only be almost like a physical network separation between the internet connection and cellular and the intranet connections through the internet. Get the log, get the real-time information, send that up in the cloud. And then from there, business application can actually provide iPads in this case to the nurses that would get real-time information on the machines. The machine manufacturer will actually start building the data lake that Jane was mentioning before to actually get the full pool of statistics on how these machines are operating and with range. And through the remote access, the remote maintenance, they can actually also provide remote maintenance services, right? Through the cellular connection, they can connect to the gateway, and then through IP forwarding and port forwarding, they can actually connect to the machines. And now the machine that had the simple maintenance interfaces running on a web application can actually be accessed remotely and provide remote maintenance services. So it's a typical use case where you had connectivity building blocks, so gateways and application logic running on the edge, IoT integration cloud. And once you start enabling that connectivity, multiple use cases start emerging, right? A benefit for the end user, in this case the nurse and the clinic, a benefit for the machine manufacturers, in this case Fresenius, and a benefit for all the installation centers. A similar use case in the consumer sector is from Ariston Thermo. So Ariston wanted to get a head start into the connected product. They wanted to be one of the first that they actually were showing, right, connected water heaters in this case and connected thermostat in the home. They actually have a home bus that connects all their home appliances. And they did not want, again, to redesign the whole product. They really wanted to start with something that they can go quick, approach the market, to do a minimal viable product approach, right? See if it gets traction, see what features are actually used by the consumers. They actually looked around. We have been discussing with them for a long period of time before we actually activated. They all went through the single vendor, right, solutions. Like these are typical solutions that, IT is the one that drives the technology, so they talk with big players and they just wanted to get something. And then they understand the locked-in, they understand that device management was a key solution. They understand that having open standards and open protocol was important. And that's when they find us, right? They said, well, if we can start with the open source, there's no lock-in. If we can start with open standard, I can start today by retrofitting my water heater with a gateway, but tomorrow I may actually be able to move into a small firmware on a Wi-Fi chip on entry-level models, just because there is the standard communication protocol, and before I can scale up on gateway, processor, operating systems type of solutions down to microcontrollers. So the winning value proposition here was, are we okay on time? Okay. The value proposition was the open source on both sides and the open standard. Again, the benefits were for multiple actors. There was the consumer that could actually control the water heater from their cell phones. There was Addison that was getting big data lake on the usage of their products. It was a curious comment that we say we were spending a lot of time and effort in optimizing my menu options, right, on controlling the programmability of your water heater, and they had no visibility on how their end user was actually using those options, right, up until they got connectivity all the way up. And then last but not least, they had an ecosystem of service centers and assistance centers that before they were actually scheduling maintenance visits just based on statistical assumptions, right, once a year. But now, through these telemetry options and the ability of actually having full visibility into the operation status, they could actually be more predictive. If the water heater got into a block state, they could actually see the reason without doing a field visit, and they could provide phone support, for example. Next use case is a connected plant. This was with Hitachi Power Solution. This is a slightly different use case, but the important part here was the governance and the privacy of the data. So when you are in a plant, and we have a lot of industrial people with industrial experience here, there is the plant owner who is producing a certain product, and there are machines in here with the machines manufacturers. Now, there is some data that is retained to the machine only, and then there is some data that is more on the shop floor, on the plant floor, and on the optimization. So when you deploy an Industry 4.0 use case, you retrofit, of course. Some of these machines have 30 to 40-year life cycles, right? So embedding connectivity into the machine is not an option, right? You have to retrofit. And you have to retrofit without creating any interference with the normal shop floor operations, right? So stay away from the control bus, let's say, right? You just read the data and optimize out of that data. So again, here the building blocks that we provide as a community, right, all together actually allows you to get a quick start on this, right? You deploy a gateway, a deploy that is able to talk the industrial protocol, the most typical industrial protocol, get the data, and then do a design decision and at the edge on what to do with that data, right? Where to send it and how to use it. In this use case, for example, all the connectivity and the device management were actually sent up in the cloud, and it was enabled for the benefits of the machine owner. While all the site data, so the plant and the operation of the line was actually kept on site and actually sent on another instance of the cloud platform that was actually doing the data lake just for the plant owner. So you could do different type of optimization. You can enable remote maintenance from the cloud, but you can also do optimizations floor at the site level, right? Maintaining the proper boundary on the privacies regarding the data. Now, this is not only for connected product, right? I mean, public transportation and smart cities are starting to adopt these type of solutions as well. This is an example where we combined also some sensors. What we see here is a people counter sensors by Eurotech itself. It's installed on a public transportation. The goal here was to actually get more visibility on people getting in and out of the different bus stops, right, or tram stops in this case, so that you can actually optimize the floor. It was just a simple logistics operation, right? How many wagons do I need at a certain time of the day? Can I actually run maybe less frequently during Sundays and Saturdays when schools are closed and so on and so forth? And the technology is fairly simple in this case. The interesting part is what you can do with it once it's collected, just the same what James was saying before, right? The public operator actually got contacted maybe 2 years after they deployed the project by the town hall, and the town hall wanted to actually set prices on the advertising billboard at each of the tram stops. And they actually wanted to do it based on the statistic of the impression that they would have got, right? Since a number of people that would have walked by that platform basically at different time of the day. And therefore, it started a whole new business basically for the public transportation operator by just having the data to resell that data to the town hall on how to use it. One last use case is on energy management. Technically, it's a very simple use case. Same story, it's a custom gateway, different protocol, but the concept is the same. What makes this different is what James was saying is the privacy and the governance. This is for a Swiss company. The data had to stay within the Swiss border. So having an IoT platform that allows you to take the same technology and deploy it locally, deploy it on the local data center is very important. And I think all the projects that we have within the of the Eclipse community, it gives you that flexibility. It gives you a flexibility of IT deployment as well, which is very important. I think this is good for now.
Yeah, I think that's it.
There is one more, but it's the same. We'll leave some time for questions.
Yeah. Any questions?
You've showed many of those use cases, and my understanding is that these are custom-built applications for these use cases. However, in the beginning, you outlined a generic architecture for such IT applications. So, would it be possible to maybe outline which parts of the general architecture constitute a kind of a reusable platform that you could reuse for multiple applications, so that you do not start from scratch from every
I'll take that.
Yeah, you go.
Yeah, and I think the purpose of those use cases was exactly what you pointed out, in the sense that we have been talking about different verticals, right? We discussed about consumer connected product, connected plants, connected services, public transportations, right? But they're all IoT, right? And by being all IoT, they all follow the blueprint that James was suggesting initially, right? I mean, you have some sensors, and you have some edge logic, and you have some integration logic in the cloud, and then you have the business application, that's for sure, right? I mean, eventually there is some domain knowledge into the data that you collect and into the command and that you activate down the cloud that is specific to the application. The point is that there is a common set of foundation that is your building block and your starting position for all of this, right? You do need an application platform at the edge that can host your application to get the data and activate something in the field. And you do need an IoT integration hub that makes it easy for you to ingest the data by especially control and all the devices that you have on the field. Manage them, change their configuration, push after update, activate and provision them, right? So these are common functionality that may be underestimated beginning when you are completely focused on your business use case. But just as you need an application server, right, when you're building a web applications, when you're starting deploying an IoT solution, you would need the three of these pieces, right? You do need a gateway platform, whether it's an external gateway or embedded in a machine, it doesn't quite matter. And you do need an IoT integration platform. And the purpose of this was just to show you how we are at the point now that I think the functionality of these building blocks is well defined enough that you can start have this generic framework as foundation building blocks for across different IoT solutions and verticals.
Yeah, directly following up on that, could you give an estimate, a rough estimate of the ratio between what is custom to the use case at hand versus what can we actually reuse from the platform?
So in all these applications, they all started with a minimal viable product type of idea, right? I mean, their first goal is let's get data out from the field and get them up into a data dashboard, right? And then your first entry level is the visualization applications in the dashboard and a small application processively on the edge, right? Then in that case, the ratio is something like 75 to 25, right? I mean, if you had to start from scratch, of course.
Meaning 75 for the usable stuff?
Correct.
Yeah.
Yes. And then, of course, from there it grows, right? I mean, if we start talking about analytics, we start talking about business models, we start talking about predictive, then it grows, right? I mean, that 25 grows. But that's the point, right? That's exactly the point. I mean, once you have more data, you can extract more value out of that data, right? The point is that without that 75, you don't start, right? It's a necessary component. It's not sufficient, but it's a necessary component. And I think what we're offering here collectively, right, is the building blocks that let you get started very, very quickly.
Yeah,
And then, the seeing is believing, right? I mean, that's what people want to see. They want to start seeing the data, and then they will build on top of that.
Yeah, and you talk about the problems with IoT, but finding a return on investment and accelerating time to market are two of the big issues with IoT. And having this base of common horizontal software that provides core functionality allows you to minimize the amount of development work you have and get solutions to market faster. What I think we will eventually see is more and more of things like Eclipse Smart Home, where you have people taking the components and other things, you know, things like Milo, and taking different pieces in Eclipse and then building an Eclipse project that's a meta project that may be a trucking application, you know, a generic trucking platform, so that you'll begin to see projects that are vertical projects built on the horizontal underpinnings, I think, as the commonality vertically becomes more apparent. But, you know, I think that, you know, it's really important that each implementer decide what their core knowledge, the core knowledge that they bring and how they can leverage it, and then try to find common ways to do common things and not spend their time maintaining a Linux distribution or, you know, a data ingestion layer or whatever, because those are, I mean, there's 80 million of those things out there. You just need to find ones that will work for you.
We can take one more question while the next speaker is set up, maybe?
Yeah.
I would like also to point out that there's at least 3, 4, 5 seats at the front, so I guess it might be uncomfortable to be sort of standing at the back. Yes, Levin?
Yes, actually I have a related question. So you mentioned 75% is reusable part, right? So, and you mentioned the ECE and ECE. So from this 75%, how much is coming from Calculum to rest? All, or is some specific developments included in the products?
Yeah. So, I think the majority of the functionality in the use cases that we've talked about came from Capel and Cura. The thing you need to understand is that Capel and Cura are built on projects that Red Hat is big in. So Camel, Drools, ActiveMQ, things like that. So, you know, there's always you decompose down into component parts. The other thing we didn't really talk about, but I think at 3:45, I'm talking with Cloudera, is the analytics piece. You know, the analytics piece is the other big piece that you're going to need, and Cloudera is a good partner for Red Hat in that area. But I mean, generally, you're looking at stuff like Spark and the Hadoop ecosystem did that sort of stuff. Although there's plenty, I know, in ODB and a bunch of, you know, there's other people here, but my experience has been in the Hadoop ecosystem. So.
All right.
Thank you.
Thank you
Thank you very much.